All right, let's talk about the Pine Valley Furniture set. What we're going to do is walk through the practice problems as were defined on the PowerPoint that was uploaded earlier. So the first question is that we want to display all of the records in the customer table. So the first thing I'm going to do is I'm going to open up HeidiSQL and I'm going to go to the PVF database. So note that we're in PVF. We don't want to use half more, half, Zaggy, Zaggy more, any of those other databases. This is the PVF database. And so what I want is to display all of the records in the customer table. And so hopefully this is an easy one. We're going to do select star from customer underscore T. Now, the reason I'm doing customer underscore T is because that is what that table is called. And so again, if you look at our relational schema, then you'll see that we don't have customer as a table name, we have customer underscore T. This is pretty typical in a lot of cases where you're going to have a specific nomenclature with these databases. And so it seems that this company, Pine Valley Furniture, uses table underscore T to indicate that it's a table. So we're going to do select star from customer underscore T. We're going to run that, and we're going to see that we have 15 rows and 6 columns. It's going to give us all of our customers. Our second question, from which states do the customers come from? And so here, we can do select customer state from customer T. And so the reason that we do that is we know that we have customer state from doing select star from customer. Then we're going to get every state and nothing else. Now, we probably only want every state once. And so in this case, I'm going to want select distinct customer state. And that's really just going to make it a little bit neater. That's not strictly necessary, although with experience, this is the kind of thing that you would probably do just by default. So here I have a list of all the states that we have customers in. You'll note that we have fewer states than we do customers. That indicates that we have more than one customer in one or more states. Our third is to list all states where customers are from and include the number of customers in each state. Don't repeat states. So in this case, I'm asking you specifically don't repeat the states. Now, the good news is that if you do group by, then by definition, or if you do group by customer state, we're not going to need to do select distinct. And because in this case, the state itself is the grouping function. Ergo, every single time you have, let's say, a customer in Florida, then it's not going to add another row onto Florida. So I want the customer state, and then I also want the count of how many customers are in each state. So just to make sure that I'm making my client happy, I'm going to do count star as number of customers. Again, this is not necessary because we didn't specifically ask for this in the problem, although this is best practice, and this is something that I would give you extra credit for. So now we have select state, customer state, and count star as number of customers from customer underscore T. Now, because I'm using this count star, I'm going to need to use a group by. And so I see that I have two elements in my select line. I have customer state and I have count star. Now, I know that my rule of thumb is that every single time I have an aggregating function like count star, what I'm going to need to do is have everything that is in the select line, every element in the select line, be either an aggregating function like count star, or is going to need to be in the group by. Customer state in this case is not an aggregating function, and so therefore I know just off the top of my head it's going to need to be in the group by. So I'm going to do group by customer underscore state. If I run that, then what happens is I'm going to get one column with the customer state, I'm going to get another column with the number of customers. And so now we can move on to the next one. So finally, which customers are located in Florida, and sort the customer names alphabetically. So in this case, I know that I have 3 customers in Florida. So I should have, so if I do select star from customer T, where customer underscore state equals FL for Florida, then what that's going to give me is it's going to limit, this where line is going to limit the only the customers that have the customer state as Florida. And so if I run this, then I see that I have 3 customers in Florida. Now there's another part, which was that I want to sort by the customer name alphabetically. And so any working query, I can always tack on to the very end, order by, and specify a column or columns that I want to order. I want to order the results by. And so I can do order by customer name, and then if I do nothing, it's going to order it ascending, which is to say from A to Z. And so in this case, if you hear nothing else, then you can assume ascending is probably what you want. You don't need to specify ASC, although if you want to wear suspenders with a belt, then you can always do order by customer name ASC, and that will specify that you want to order it by the customer name ascending. In this case, the customer name was already ascending just by default, although you can imagine a situation wherein you would not want to assume that this is the case, and so therefore we would want to actually specify that in the query itself. So now that we've done this, let's go ahead and move on to the next question, the next slides. Okay, so now for slide 2, or for problem set 2, we're going to want to use multiple tables. And so remember that every single time we use multiple tables, we are going to need to join them in some way, shape, or form. Now the easiest way to do this is going to be through Cartesian joins, which is what I've normally been doing in class, although in certain cases we are going to need to use the join keyword. So let's look at the first question here, which is which customer placed order 1006 and list the customer name. So if I just do some exploratory work here, I can do select star from order T, and so I can see all my order IDs here, and I can see that order ID 1006 was placed by customer ID 2. And so if I look for select star from customer T, I run that, I can see that customer 2 is Value Furniture in Plano, Texas. So I know that I should come up with Value Furniture in Plano, Texas. And if I did this the long way, by just checking these tables, then I would come up with that answer. But I don't want to do this the long way. I want to be able to do this quickly. So let's say I want the customer name from the customer table, so c.customer name, from customer underscore T, C, and order T, O. Now I need both of these tables because I have the customer name in the customer table and have the order ID in the order table. So I can't do this with only one table in any case. I need both the order table and the customer table. So now I have two tables in here. So the first thing I'm going to do is I'm going to join these tables together. So I'm going to do where c.customer ID equals o.customer ID. And now I know that I want to use the customer ID equals customer ID because that key pair is specified in the relational schema as the foreign key and the primary key combo. Now I also want to list this as also I only want order ID number 1006. So I'm going to do and o.order ID equals 1006. And if I run that, then I see that I get Value Furniture. So again, I have the answer that I was expecting, but in this case, I don't need to go through as much effort to find it. And indeed, if I needed to find another order like 1009, I could easily do that by just changing the number in that order. So next question. Next question is, what was on order 1001? Include all fields from the order T and order line T tables. So, I want to include everything in the order T and order line T tables. So now I'm going to do select star because I'm just going to pull everything from that order T. So from order T O and order line T O L, where order.order ID equals order line.order ID. Again, we know that we need that because that is the key pair that is specified in that relational schema. So if I run that, then I do not get I get all of the order and order lines, and so I also want to specify and order.order ID equals 1001 because that is the order I'm interested in. And so here I see that I have 2 of product ID 1, I have 2 of product ID 2, and I have 1 of product ID 4. And so this meets the specifications of the question itself. Next one, for each order, list the order ID, the date, the customer name, the total number of units, and the total price of the order, assuming that everyone paid standard price. So that we're in this case, we're just saying don't worry about special prices. We indeed have a standard price line here. So what we're going to want to do is we're going to list the order ID, which is in order, the date, which is in order, the customer name, which is in customer, and the total price of the order, which is going to include the order quantity and order line, and the standard price and product. So I'm going to need to pull from customer and order line and product. So let's go ahead and take this one little bit at a time. So first, list the order ID, the date. So I'm going to do order.order ID, order.order date, and just order underscore date. The customer name, which is customer underscore customer name, c.customer name, and then the total price of the order, assuming that everyone paid standard price. So the total price of the order is going to be the order line dot quantity times order line product dot standard price. Now we know that an order can include multiple products and multiple quantities. And so we're going to actually need to group these together. So we're going to do sum of the order line quantity and the standard price. And we're going to have to come back to that later. But the first thing is we're going to need to say from the tables that we want. So from customer underscore T, C, from order O, from order line, and then product P. So I have more than one table, which means I'm going to need to join these all together. So again, I'm just going to use I'm going to path across the relational schema. So from customer to order, I'm going to use customer ID. And from order to order line, we're going to do order ID. And from order line to product, we're going to use product ID. So finally, now we have all of these together, and we have this sum up here, which means that we're going to need to have a group by because we have these other lines which are not in the group by. So because everything that is not an aggregating function must be in the group by column or group by line, we're going to have we're going to need order ID, order date, and customer name to be in the group by. This order line quantity times standard price is an aggregating function. So I'm going to do group by, and I'm going to copy this, just to make it easier myself, and paste it. And I'm going to run that, and I'm going to get an error because I misspecified the quantity. It's ordered underscore quantity, not quantity. Ordered underscore quantity times P to standard price. And so you'll see that for every order, I can see the date that this order was placed, I can see the name of the customer, and I can see the total price of the order. Now, one thing that I might want to do here is that I see that this column 1 is not exactly ideal, so I'm going to do as total cost. I'm going to rerun that, and now I have total cost there. Okay, and then finally, list all product information, including the product line name for our most expensive product. So if I wanted to find what our most expensive product was, then I do select max, standard price, from product underscore D. And so I can see that the highest price item we have is $800. And so now if I wanted to get all the information about that product, I can do select star from product underscore T, where, and I'm going to do this on multiple lines because I want it to look pretty, where standard price equals 800. Or in other words, where the standard price equals the max standard price. And so now I can see that this is a dining table made of natural ash. Now I want the product line name, which is in this product line table. And I know that I have the product line ID here. So instead of just doing select star, I'm going to do from the product T, I'm going to do from product T, P, and product line, underscore T, PL, where the standard price equals that subquery, and product.product line ID equals product line.product line ID. And so now I can see that I have the product line ID and product line ID here, and the product line name is Scandinavia. So this qualifies, this meets all of the everything that I was looking for, which is that it includes all the information on the product, including this extraneous field, which I don't know how that got there, and then also everything that's in the product line table, including the product line name. So now let's move on to the third slide. Alright, so now let's consider the third problem set, and these are all pretty closely related to each other, so let's take these in sequence. The first thing we want to do is list all customer names. So this should be pretty straightforward at this point. I'm going to just use select customer name from customer underscore T. And so here I can see I have all of my customer names just listed out nice and in order. So now the next thing I want to do is list the name of all customers and the number of orders that they have placed. So in other words, every single customer who has placed an order should have be represented by a customer ID in this order underscore T. And so this gets into our into the problem of what happens when we have a customer who doesn't place any orders. And so let's do this. Let's just do select customer name from customer C, comma order TO, and so then I'm going to do where c.customer ID equals o.customer ID. And so you see that we have 15 customers here. So if we run this, suddenly we have 10. And so you'll note that what happens is that any customer who has not placed an order gets excluded. And the reason why is because this Cartesian join is de facto an inner join. And what an inner join means is I only want you to return rows where the I have a customer ID on both sides. So where the customer ID in C equals the customer ID in O. And so in this case, I have 6 customers, and so mind you, Contemporary Casuals has made 2 orders. I have 6 customers of my 15 that have not made any orders at all in this database. And so this is where I want a left join. And so when I have customer C left join order T, and then I'm going to change this to on because that's a component of the left join keyword. What I'm saying is give me every single column in the customer table, and if there is a match on this key pair, then I want you to show me that match as well. So let's do just as a check on this. I'm going to do order ID, and so we should have some customers who have null on their order ID. And so again, customer C left join order O. What that's saying is the customer's on the left side, and so therefore I want every single row on the left side. If there is one or more rows that it matches up with on order, I also want those, and I want you to give me the order ID. If there is no order ID, then I want you to show me a null. So I'm going to run this, and I can see that Furniture Gallery, Period Furniture, and others all have nulls there. And indeed, Contemporary Casuals again is listed twice because they have 2 order IDs associated with them. Now, in this case, I don't actually want the order IDs that they have. Rather, what I want is to return the number of orders that are associated with them. And so I'm going to do count o.order_id. And so the reason that I'm doing count order ID and not count star is because I only want you to count the number of non-null values which appear in this order ID. And so Contemporary Casuals, for example, should have 2. Value Furniture should have 1. Furniture Gallery should have 0 because Furniture Gallery only has null values. Now, this is splitting hairs a little bit, and this is something that is only going to appear on this practice set and maybe in some homework. This will not appear on the test because I think that this is a little bit beyond what I would want you to know off the top of your head. Having said that, if you do this in your professional life, then this is something that I do hope that you'll remember, and or you'll come back and watch this video fondly. So I'm going to do as number of orders, and of course I have this count, and so I'm going to need to do group by, and so my grouping variable is going to be customer name because that's the only thing that's the only other thing in there. So group by customer name. I'm going to run that. And now I can see that I have, exactly as I expected, Contemporary Casuals has 2 orders, Furniture Gallery has 0, and Value Furniture, I think, was the other one. I forget which one I was looking at. Has one order. Now, so that meets that is number 2 that we answered. We want to list all the names of the customers and the number of orders that they have placed. This list should include customers that have not made any orders. So now we want to list the names of customers who have not made any orders. And so again, we have this group by, and so what we're trying to do is take this list that we have and pare it down into only the customers who have not made any orders. So in other words, we want where this number of orders equals 0, or more specifically, where count order ID equals 0. And so you can see straight out that this would not work if we had this listed as if we did not use left join. And in fact, let's look at what happens if we don't use left join. From customer C order T, where, and so you'll see that because that I'm not going to have any of my zeros as I expect. So going back to this, because I'm trying to toss out groups that do not meet a criteria, I'm going to use having. So having count o.order ID equals 0. And so in other words, I only want to return the the rows where the count is 0. And so I'm just going to add that having on there. I'm going to do that, and I'm going to return only the list of customers who have not returned any orders. Now, something that is important to point out, having reduces the set of groups, whereas if I wanted to reduce the rows that go into that group, then I would I use where, and that where would toss out rows before they hit the grouping stage. So if hypothetically I wanted to, let's say, only show customers who had purchased natural ash furniture, then I would use where, because that's a row by row issue. Now, having count, in this case, that count is a group by group criterion, because in this case the number of orders is a feature of the group. So I thank you for watching this. Again, if you have any questions, go ahead and email me, and I look forward to that and seeing you again on Thursday.